Hey everybody, welcome to video 33. Today we get to talk about the cerebrum. So now we're starting to get into some of the parts and some of the organs that you have in your nervous system. So we're going to see cerebrum today. We're going to get into things like the diencephalon, the brainstem in the next video. So now we're going to take a look at the cerebrum, which is what we normally think of as the brain. So the cerebrum, you can see there, the external structure of it, so the part that we normally see and that we normally think of is known as the cerebral cortex. Now your brain is not actually all multicolored like this one here. This brain is useful for identifying some of the areas that control certain things in the body. And we'll get into each of those colors here in a little bit. But it is divided into a right and left hemisphere divided by the longitudinal fissure. So even though this one is artificial for this brain, you do have a longitudinal fissure that separates the brain into the right and left hemispheres. And I can even separate these here with a little bit of work so that you can see each of these hemispheres. I have a right hemisphere and I have a left hemisphere. Inside the cerebrum, deep inside here, you're going to have the corpus callosum. Now, the corpus callosum is going to be responsible for connecting your right and left hemisphere and allowing them to be able to communicate with one another. Here you can see where it is deep within. You can see that longitudinal fissure. But without that corpus callosum, the right and left hemispheres would operate independently of one another outside of where they would connect in the brainstem and things like the diencephalon. So that corpus callosum is very important for being able to have both sides under control of one brain. The cerebral cortex, the outermost portion here, the cortex, is a continuous layer of gray matter. So we saw in a video earlier the difference between white and gray matter. And you even saw a little bit when in a picture of a brain that was sectioned, and you could see that gray matter running along the outside there. The cerebrum and the cortex is very, very wrinkled. So I don't know, you can definitely see the wrinkles that we have on here. The ridges that you have, so it'd be like the mountains, if this were some sort of weird mountain range, are called gyri, and then the valleys or grooves in between them are called sulci, or the plural or the singular of these would be a gyrus and a sulcus. But the reason that you have these is that it allows you to fit way more gray matter inside your cranial cavity. If your brain was completely smooth, you would have much less brain matter and much less information that you'd be able to store inside your brain. And then the size of your cranial cavity in the first place is naturally selected by the birth canal, whereas if a baby's head is too big, it was much less likely for the mother to survive labor, but you want that head to be as big as possible so that you can be smarter, essentially. So you have that stabilizing selection between trying to get as much brain matter as possible in the cranial cavity, while also needing for mother and baby to survive labor. On the cortex, these gyri and sulci also provide very natural divisions that we can see in the cerebrum. We'll get into those here in a bit, but you can see one of the major ones, and it's even color-coded, separating the red and the purple here. That is a major gyrus called the central sulcus. For the lobes of your brain, you have the temporal lobe. So remember, the temporal region is going to be back here. You even have the temporal bone sitting back here. And so you have the temporal lobe. It's going to be this little Bluetooth headset looking thing coming out the side here. It's going to be separated by the lateral sulcus. So you can see this lateral sulcus running down here, separating the temporal lobe from the rest of the cerebrum. You have the parietal lobe. Remember, your parietal bone is on top here. So that is where your parietal lobe is going to be up here. Frontal lobe, remember the frontal region, the frontal bone, the frontalis muscle. Now we also have the frontal lobe is going to be this front section here. It's going to be separated by that central sulcus that I already pointed out running through there. So everything anterior of this is going to be the frontal lobe. And then we have the occipital lobe on the back. Now note, the occipital lobe is not this structure here. This is a separate structure. This is the cerebellum. This here is going to be your occipital lobe, right back here. Okay, here you can see some more divisions there, that frontal lobe and the central sulcus. You'll see they have the precentral gyrus and postcentral gyrus, the names for the ones that are immediately anterior and immediately posterior to that central sulcus. You can see that temporal lobe and then the occipital lobe here. There's an imaginary, it's not really very well defined, the parieto-occipital sulcus separating the occipital lobe and the parietal lobe. Since it's pretty poorly defined, we really don't consider that sulcus in this class. The cortex can be divided into 52 different regions based on what information is coded for in each of those regions. They're called Brodmann's areas, named after Corbinian Brodmann, who first discovered these regions back in the 1900s. And so he broke these down into 52 regions based on what was being controlled in each region. I'm not going to expect you to know all 52 regions. I'm just going to highlight a few important ones here, starting with areas 1, 2, and 3. So areas 1, 2, and 3 is going to actually run, I'll center this up here, the red and white running down through here. On this side it is completely red. It's known as the postcentral gyrus, or most commonly you're going to hear me call it, or sorry, I got this wrong. Postcentral is posterior. It's going to be the purple running through here, and especially you can see on top that purple and white. That was almost a bad deal. So postcentral gyrus, posterior. You're going to hear me usually call it the primary sensory cortex. You may also see it as the primary somatosensory cortex. Based on senses being in the name there, it's responsible for all of your touching sensations. So we'll look at this brain in class one of these days, but you can see it goes through there. You won't be able to see on the video, but like hip sensations, torso sensations, neck, head, shoulder, arm, hand, fingers, thumb, eye, nose, face, all the way down. All of your touch sensations are going to be controlled in the post-central gyrus right there. Area 4, which is what I was talking about earlier, is the precentral gyrus. You'll hear me usually call it the primary motor cortex, is then going to be responsible for controlling skeletal muscles and controlling a lot of those areas that the precentral gyrus is sensing. So again, you have the hip, trunk, shoulder, arm, wrist, hand. It almost goes in the same order as it does on the postcentral gyrus, starting here and working its way laterally. Areas 44 and 45 are going to be this purple area right here. This is known as Broca's area, but it's going to be responsible for the motor movements responsible in speech. So being able to move your tongue, being able to move your orbicularis oris muscle and everything associated with being able to actually physically talk is controlled by Broca's area right here. So that is a very important area of the brain, especially as humans, where we all like to talk. Here you can see some of Brodmann's original drawings here, how he had labeled the primary motor cortex, the primary sensory cortex. You have Broca's area there. You can see an area where auditory cortex, where audition, hearing, is controlled, as well as a few other things, the visual cortex on the occipital lobe. That's why if you get hit really hard in the back of your head, you can actually see stars, because that is where vision is controlled in the brain. And then I also want to talk about the meninges. There is no meninges on the cerebrum here, but the meninges are a series of very protective coverings for your cerebrum. So you're going to start with the dura mater, which is literally translates as tough mother, no joke. but it's a very, very strong and thick, as well as a very fibrous layer that's going to cover the brain as well as the spinal cord. So you'll see it responsible for protecting your central nervous system. It's going to be anchored to the inside of your cranial and vertebral cavities, meaning that it's going to be anchoring itself right up against the bone, especially in your skull. It's going to be anchoring to each of your skull bones that you have. The arachnoid mater is going to translate as spider mother. And it gets that name because it's very, very web-like as you peel it off and as you look at it. A layer of tissue. Basically, it's going to create kind of a loose sac around the brain and spinal cord and will be deep to the dura mater. Then you also have the pia mater, which translates tender mother. That's going to be right up against the gyri and sulci of the cerebrum, as well as right up against that spinal cord to protect them. It's not nearly as tough as the dura mater, but it does make sure that it is right up against those gyri and sulci in order to best protect them. Here you can see that dura mater on the superficial most layer of the mater. The arachnoid mater, especially that subarachnoid space, is actually where the arachnoid mater gets its name. And then the pia mater will actually go into each of those sulci so that it's making sure that it is adjacent to them at each point. So that is a little bit about the cerebrum. Obviously, there's no way we could realistically cover anything or everything there is about the cerebrum. So if it's something you're interested in, if you have questions on, feel free to consult either the textbook or ask questions. I may not know all the answers. Nervous system tends to be the one that people have or people tend to stump me on the most, but I'm always open to being able to learn something new.